Hello everyone, how are you all? I hope you all are good. So today we will discuss about the topic IPv4 header. So in this video we will learn about the fields the IPv4 header contains, each working of each field, and what is the length of each fields in the IPv4 header. Let's we get start. This is the structure of our IPv4 header. So the IPv4 header contains total 12 fields. Okay, these are the 12 fields. Then our version field is of 4-bit. Then we have the IHL, which stands for Internet Header Length, which is of 4 bits. Then we have DSCP and ECN. We will discuss about this both topic later. It contains in TOS, type of service, which is of 8 bits. Then we have total length, which is of 16 bits. Then we have identifier, or we can say identification, which is of 16 bits. Then we have flags, which is of 3 bits. Then we have fragment offsets, which is of 13 bits. Then we have time to leave, which is of 8 bits. Then we have a protocol, which is of 8 bits. Then we have a header checksum, which is of 16 bits. Then we have a source address, which is of 32 bits. Then we have a destination address, which is of 32 bits. Then we have a option, which is comes from 0 to 40 bytes. Okay, as we all know, 1 byte is equal to 8 bits. Okay, then IPv4 header is of 20 bytes in size, and it may extend up to 60 bytes, including optional field. Okay, how the header look with our data is, this is our data and this is our header. As the data share in packets, in the form of packets, there each header contain with the data. Okay, then transfer. Okay, I hope you understand. Shall we proceed? Okay. Then we have our first topic is version. Version. The version is the number of the IP protocol. For IPv4, this field has a value of 4. If we have IPv6, this field has a value is 6. Version field of IPv4 is equal to 0100, and version field of IPv6 is equal to 0110. Then we have the topic IHL, Internet Header Length. Okay, the length of entire IP header. Okay, the value of IHL field must be multiplied by 4. Okay, to get the length of our header in bytes. Okay, for example, let's we take, you always a C5. Okay, 5 meaning that the header length is 20. How? 5 into 4 bytes is equal to 20 bytes. Okay, and this is known as scaling. Okay, the minimum value of entire header is 0 and maximum is of 60 bytes. Okay, then just wait for a second. Right, this is the data, this is our header, this is known as datagram. Okay, then we proceed for our next. Shall I rub this? Okay. Okay. Let me proceed for next. Then we have a TOS, type of service. It has various purposes over the years and has been defined in different ways by 5 RFS. Okay. The TOS field could specify a datagram priority or request router for low delay, high throughput, etc. Okay, request router for low delay. TOS is used for quality of service purpose. Higher priority data should be processed first. In TOS, higher bit value has more priority. For example, 001 is for priority, 010 is immediate, 101 is for critical. Then we have a DSCP in TOS, differentiated service code point. This field is 6 bits, used to be called TOS. ECN, explicit congestion notification. This field 2 bits is used for end-to-end notification of network congestions. It has following meaning. 00 non-ECN, capable transport, non-ECT, non-ECT. Oh. Sorry for this. Then 10 ECN capable transport, ECT 0. 01 ECN capable transport, ECT 1. 11 congestion encountered, CE. Then we have total length of entire IP packet including IP header and IP payload in bytes. Okay, the minimum value of 20 bytes since the minimum IPv4 header length is 20 bytes. The length of field is 16 bits. This means the maximum length of one IP packet is 2:16 bytes, which is equal to 65,536 bytes, including the header. The minimum length of one IP packet is 20 bytes, which is the case in which there is only IP header and no payload. Okay. Then we have the topic identifier. If IP packet fragmented during the transmission, okay, all the fragment contains some identification number, a unique identification number to identify the original IP packet that belongs to. It has the identification number which is helps to identify the original IP packet. If IP packet is fragmented during the transmissions, all the fragments contain the same identification. Okay. Okay. Then we have a topic flag is so important as it required by the network resources If IP packet is too large to handle, these flags tells if they can be fragmented or not. In this 3 bits flag, MSB always sets to 0. Means bit 0 is reserved, must be 0. Bit 1, don't fragmented. Bit 2, more fragmented. For unfragmented packets, the MF flag is set to be 0. For fragmented packets, bit 0 set to be 0, bit 1 set to be 0, and bit 2 is set to be 1. However, in the case of fragmented packet, all bits to be fragmented as 0. Okay, set as to be 0. Then we have the topic fragment offset. This offset tells the exact position of the fragment in the original packet. Exact position, it will tell the exact position of fragment in original IP packet. Okay. Then we have time to live. Time to live to avoid looping in the network. Every packet is sent with some TTL value set, which tells the networks how many routers this packet can cross. At each router, value is reduced by 1. Let me give you one example. This is our sender. Router 1, router 2, router 3, router 4, router 5, let me take only 4 routers. Okay, then we connect. This is our sender. This is router 1, R1. This is router 2. This is router 3. This is router 4, and this is our receiver. Okay, or we can say destination. So in this TTL, what we have target, this we have after 4 routers we have destination. Okay, send the request. This is our first router, started with 4, then comes to 3, 2, and 1. After 1, go to 0, which is our destination. Okay, so in TTL, at each router, value is reduced by 1. And TTL, how many routers this packet can cross, shows you. Okay, tells the networks. Okay, I hope you understand this topic. Shall we remove? Okay. And then go to next. Then is our protocol. And also TTL, first one thing left, TTL benefits to avoid the looping. Okay. Then we have a protocol. Protocol tells the networks layer at the destination host to which protocol this packet belongs to. For example, TCP is equal to 6, UDP is equal to 7. Then we have header checksum, which is used to know for the error for free transmission. For error free transmission. Thanks. Hope you all learn these concepts easily or understand. If you have any query or have any issues, let me know in the comments. Thanks for watching. Bye bye.